Good morning. Welcome to episode 144 of the Driller Newscast, your weekly update on all things that are innovating, impacting, and inspiring the drilling and construction industry. I'm your host, Brock Yorty, and this week I am so excited. We're continuing with Soren Soe, and we're going to jump into all of the fundamentals and the advantages and where we should utilize this tool in coiled tubing rigs. And I'm so excited. But before we jump into this, let's do a check-in. How's your team? How's your safety going on? How has this first several weeks of the new year been? I need you to start considering, with all of the different flus and resurgence of some COVID and thing, we need to be thinking about our health. But most importantly, there's a lot of turmoil going on, and we need to be thinking about that mental health and how that could possibly be distracting our teams from finances to people's jobs elsewhere, or how we are interacting with the rest of the world. So teams, it's very important right now for you to jump in and have that discussion of, do you like what you're doing right now? Is there anything I can help you with? Do you feel safe? Let's work better together. Let's jump into this great conversation with Soren Soe. Shifting gears, you started out designing rigs that were conventional rotary, conventional, pull down and pull back. And you shifted to coiled tubing. Our industry, we have had coiled tubing rigs come in from the oil field that were used for fracking and for other pieces. We have geothermal companies here right now touting different, coiled tubing packages and tooling. And I don't want to compare, but 90% of our industry is conventional rotary machines. And can you give us the breakdown of how we're doing it differently? Because it's like trying to drill with a noodle versus a stick. And I think we get very stubborn headed to go, wait, that doesn't make sense to us.
Yes, a handful of drill rigs. This is rough number, right? There's just over 2,000 in total coiled tubing rigs on the planet in total, right? And the majority of those, let's call it all of them, pretty much works in oil and gas. And it's only, 6 to 8% that is actually used for drilling. A lot of them are used for workover, as you said, and they're big. They're really big, big rigs and big monsters, so to speak, from a geothermal point of view. And you can say so. So there's a limited amount of meters actually drilled in open ground. But I guess that there's some significant differences between let's say a conventional drill rig using drill rods and a coiled tubing rig. I guess the first or the visible difference is your drill string is one continuous length of steel that you coil up or basically roll out into your borehole continuously, right? And there's a number of challenges doing that, and some opportunities and advantages. The challenges are that it's the same thing with a paper clip. You bend and stretch a piece of metal, and it breaks. So it's something you can do a kind of a definite number of times, but you can definitely consider it like your garden hose in your roll up. So it's a very quick way of pulling something up or down. It's been around for a lot of years. It's been used for drilling for a lot of years. So it's not a new technology. It's been used predominantly in oil and gas, as we talked about. But now it is moving into different industries, and that also means it needs a different cost structure than has been existing in oil and gas, right? The dollar per foot, if you look at it like that, is very different in oil and gas and geothermal and potentially mining as well. So there's a number of challenges doing it. Some of the work that I got involved in with that was, you can say, improving that. We can talk a bit more about that. But the differences are also your drill string is not rotating. So you don't have a rotation unit at the surface. You have an injector, as we call it, which are a set of grippers that are, let's call it, pulling and pushing your drill string in and out of the ground as you drill. And at the bottom of your drill string, you have, we call it a bottom hole assembly or a BHA. You have various tools to cut the ground depending on what ground you're in. And to simplify it, you can say there's a couple of different versions, either whether you're cutting soft ground or hard ground. I know that's a simple way of expressing it, but that's you can divide it into that. What is you can say what pans out to be the differences in the actual drilling is you once you start drilling, you're continuously drilling. You don't stop and start to add a drill rod or take it off. So once you have your circulation going, it's a continuous process. It also means that at most of the time to actually do the drilling process, there's one person needed. You don't need an offsider every 20 feet or 40 feet to change your drill rod. It is continuous, and that has of course an impact on productivity because you don't. I mean, drilling a 500 feet geothermal borehole, you would have, 25 rods, and you need to put 25 rods together going in, and you need to put 25 rods apart pulling out, so that, 50 connections you have to make every time you drill a 500 feet hole. And if you do whatever, let's say you have a good day, you do 3 of them a day, that's 150 rod connections you're doing. Unless you have to stop somewhere in between and change a drill bit, then you have to sort of reverse it a bit more. In coiled tubing, you just do that. You can say you set your feed system depending on how you're drilling, and it just looks after itself sort of. If you need to, you can say change a drill bit, as I mentioned. You just coil your coiled tubing up, and you can do that. It's a matter of minutes pulling out from 500 feet. So if you need to change a drill bit, less than 5 minutes pulling out and change your drill bit, and less than 5 minutes going in is you can say which is really affects the productivity. And people might think, oh, if you're pulling out at 80 or 100 feet a minute out of a borehole, you'll suck it in. But one of the things you can do with coiled tubing, and you do it, is you continue your circulation as you pull in and pull out. So you're actually not destabilizing the borehole as much as you do with conventional drilling. Every time you add a drill rod or take it off, you pulsate your borehole a little bit because you start and stop your circulation, which gives you these fluctuations. You don't do that with the coiled tubing for starters. So your borehole stability, just per definition, is way better. And we see the proof of that while drilling. So you can, in a lot of cases, if not all cases, get away with way less casing. Because if you pulsate your borehole, typically you have to put a lot of casing in just to keep your borehole stable. We get away in coiled tubing drilling with very little casing, if any, which are some of the differences in that. So the productivity side of it and the safety, not having to handle all the drill rods is significant differences. You can say that when it comes to the you can say some of the indirect benefits you see from drilling is because you are spending more time on bottom, your productivity is up. 30% is not uncommon when it comes to drill in pure productivity improvements. And then you have to, you can say you're actually having quite significant savings on your consumables. We on the benchmark tests that are out there and has been for a year, you're saving on fuel. You're saving on water if you're drilling with a water-based drilling mud. So there's significant savings if you compare the two drilling methods. Some of the challenges that exists with coiled tubing compared to conventional drilling is, as you mentioned, that the drill string is generally a smaller diameter than what you would have from drill rods. and you're looking at it as a piece of spaghetti or a shoelace in the borehole is not far off. So per definition, it is a low weight on bit drilling method. So you don't want to push a coiled tubing drill string the way you could push a conventional drill rig, which means the drilling methods are slightly adjusted to that way of drilling. And if you adjust you can say the two ways, if we want to put it in simple terms, if you want to compare it to mud rotary, for instance, we have you can say we're drilling with, a few stabilizers potentially, but a downhole motor, and then you have the type of bit you potentially would choose for a conventional drill rig, and you have your fluid system, going. You might have to, and you can easily push. It's not that you can't push on a coiled tubing drill string, but the limitations will be reached before. If you're drilling, let's call it harder formation, like rock, granites, everything like that, you want to drill with a percussive tool. I mean, you use less energy per meter drilled using a percussive tool, and you would probably shift to air drilling if you were on a conventional drill site and start your compressor and do all of that with the challenges you have if you're in fluid and water. But on a coiled tubing drilling rig, you can drill with a fluid hammer. That has also been around on coiled tubing since the late 90s. Drilling with a fluid hammer has some advantages over air hammers. First of all, you don't compress air, so the energy consumption to run a fluid system is way less. You're not compressing air 40 times. It's a hydraulic way of drilling, and so it's very efficient. And you drill with higher pressure, so suddenly your pressure jumps from 1500 psi to 4000 psi. So your drill string become a hydraulic system. Even if you have a failure or something goes wrong, it's still fluid water coming out. So it's not like air that it's just like it's fairly safe. Even if you have you can say compressed fluid coming out somewhere. So that's you can say some of the differences. And drilling with a fluid hammer, you can drill very hard formations without any weight with very low weight on the bit if you need to. That's some of the differences. So we see increased borehole stability, way less manual handling by anyone because you can't actually, and you can have becomes a very compact design. Your drill rig and your fluid system and your drill string is all contained in you can say the volume you would see of a drill rig. You need a system to process your fluid. You want to clean your fluid as you go, so you would have a fluid system doing that, but you can park that away from the rig if you need to put it into constrained spaces. So yeah, you have a very compact system where you have to really try hard to not it's to a large extent one person operated. You need more than one person on site, but the actual drilling is one person operated. Yeah.
Okay, so we have no weight on bit. We're using high rotation to be able to penetrate the hole, but the tube, like you said, a shoelace or a noodle, it has memory and elasticity to it. Does it become rigid as we put it into, a vertical point? Is there, like, as it's in tension, is it more rigid than what it is when it's in the coil tube? I think that's a big piece that the industry is like, how does this work?
Yes, how that works. It's actually a high tensile piece of steel, and the sizes that are used in geothermal are 2 and 3/8 or 2 and 7/8. So that's the size of your drill rod. So it's a 2 and 3/8 or 2 and 7/8, and you can have 2 or 5/8. That's the range in what we would call the shallow geothermal size. You can have smaller. One of the things that you can probably characterize the coiled tubing rigs I've been involved in is addressing, you can say that steel. All of the other so far companies in the industry would have, like the oil and gas companies, they would have the coil tubing on the back of the rig or on another rig. And what you can say, the thing about bending and stretching the paper clips on all the conventional drill rigs, you would have going in the hole and out of the hole, you would have that movement, let's say 6 events, right? Because you're going over your gooseneck, as we call it, what the thing that guides it into the injector, and then you can say you stretch between the gooseneck. So you have six events. The first coil tubing rig I was involved in the mid 2000s was the first one where we put the reel on top of the borehole. So you reduce those 6 bending events to 2. So you'll probably the rigs you see out there with a tubing on the mast directly above the borehole. I probably have been involved in some of them. We have compared to, you can say, a standard steel tubing used in coil, in oil and gas, and a conventional setup. And there's a number of things that defines the life of the coil tubing. We have seen coil tubing rigs from the standards that has a fatigue life of, you can say, 40 you can say trips in and out of the hole before you actually have a failure of the steel. The rig we are having here is the number is 600, about 600. But it's about making it cost efficient in a different industry, because 40 would not work in geothermal. If you drill 40 holes, you have to change your coil tubing and throw it out or whatever. We have 600, and there are models that are operating in the minerals industry where the fatigue life is even higher. But it is not getting, it does harden over time, but you would have around 600 trips in the hole. Yeah.
So tripping in and out is the most impactful. So right now in the States, the projects that have been used to drill with a coiled tubing rig for geothermal have all went much deeper than what we had been used to in the industry, pushing or advocating for holes that are 1,000 to 1,500 foot. And that's because you could drill 1,500-foot holes 40 times, or you could drill 600-foot holes 40 times, but you're getting into that fatigue with what's happening. And so the more time you're in one hole and the deeper you can go, the more footage you can get out of one single coil.
That's right. That's exactly right. That's right. I mean, I guess the economy. I'll not pretend to be a specialist on the economics of geothermal, because there's loop sizes and pumping efficiencies and all of that goes into the depth. What I can say is that the deeper you go with coil tubing, the more efficient it gets, so to speak, and the easier it is to address if you want to do something you can say, change your beater or something like that. That's where it really proved. But the rig we have for the geothermal has tried to address the need for holes. You can say for in the range from 500 to 850 feet, but there's nothing limiting it going even deeper. I mean, some of the equipment we have developed for the minerals industry is way deeper in using coil tubing. So the depth is not the challenge, but the benefits are, you can say, using less casing, better borehole stability, all of those, less injuries, faster drilling. All of that comes, you can say, as benefits from coil tubing drilling. What we have done, because we worked with a number of the drillers in the US to optimize this technology for their specific needs. So some of the stuff we have addressed is that, and trying to, not all you can say drilling operations go to plan, right? you pull out of the hole, and the last, you try to put your geo lube in, and there's whatever 5-10 feet of the bottom of the hole that has collapsed, and you have to go back in and drill it out to get your lube in. We can install the lube with the rig remaining over the hole. So the minutes it takes to get your geo lube in the ground, you don't have to move the rig. And if you need to pull your geo lube out and go back in and re-drill the last 10 feet for whatever reason, it's a very easy operation. I mentioned it takes minutes to go back into the hole, clean it out, and come out again to give that another try. So that's been some of the things we've tried to address. Also, differences between conventional drill rigs and coiled tubing is that the tooling, can be fairly long. The downhole motors and whatever tools you have, we don't have to disconnect them between the holes. So if you have, many boreholes, as you sometimes do, 20 feet apart or whatever, you basically don't disconnect anything. You just, once you've done with one hole, you move on to the next and continue your operation. So, doing coiled tubing rigs for different industries definitely had different needs. Because drilling a 6,000 feet, coiled tubing hole in one location, moving between holes is not as important as if you do, a series of 400 feet holes.
So you're monitoring and the life cycle of your coil. How hard is it to change a coil?
I won't say it's not like a quick connector, but it is something that can be done in the field. What we've done with our rig, you don't have to take the rig off site. You need a crane to lift the coil because the coil is, it's heavy. You have it's for starters equipped with 1,000 feet of drill string just to have, if you need to cut something off, you can, but you would have sufficient for that. But you can disconnect the reel, leave it. You can say you leave it on the bed of the body of the rig, and you have to have a crane in to lift the old, disconnect it from the rig, lift the old coil out, and then you can put in a fresh coil, put that into the injector, and ready to go you are again. The more times you do it, the quicker you get. So it can be done. You don't have to take it to a factory or something like that. Everything is easier if you're in a factory, but you can do it in the field if you have to.
So what have been the barriers of seeing more drilling companies accept, coiled tubing for geothermal?
Trying something different, trying to understand it different, right? You had a very interesting podcast early in December, where the discussion was that every driller was the best driller. And I thought it was a very interesting, reflection on how drillers think. And it needs some courage to try to do something differently. And there are many, you can say, different industries have different drilling characteristics. I would say different, you can have a diamond driller in one end, which is a one set of skill sets. You can have a water well driller. You can have, hammer drillers. There's all these different skill sets. And there are probably some industries that are easier to adapt to coiled tubing drilling. And that's probably also why as you mentioned, there's a good handful of companies that are seeing the benefits of coiled tubing drilling for geothermal. So it is getting adaptation to it. But I think you need the first movers and our first clients. They want to make a difference. They see the benefit. They want to have that you can say productivity improve in terms of rod automation all in one, right? They want to have the productivity on all the aspects, and want a better hole completion rate in their system. So they're determined that this is the right thing for them. We have tried to do it around their workflow, so it should be fairly easy. But I understand it. When each of us does something else, we tend to pick up the phone we had before. We buy the same car. We do the same thing to to it's you need a significant number of first movers to demonstrate that this is it, right?
Yeah, yeah. Early adoption's hard because I know some drillers and rig manufacturers that go, listen, we like being on the leading edge, but not the bleeding edge, and so
Yes.
as you decide to put it all out there, it's everywhere it's successful, you got one more step, one more piece person that wants to adopt, but at the
Yeah.
same time, there was a project in Ohio where uh coil tubing was the wrong application or
Okay.
the operation or how they laid it out. It just was not, it wasn't the most efficient way to complete those holes.
Okay. I mean, there's a tool for every like on every drill rig. You need persons who needs it to work. I think some of the barriers are also organizational, I would say. I think there's different decision-making processes in smaller companies and bigger companies. And I worked in bigger companies as well, also, holding senior positions. So I also know what the decision matrix is in a bigger company. And one of them is risks, right? And if a senior manager has to put his neck out to say, yeah, we're ready to give this a go, and everybody will criticize him. And if it's not the right thing, it's his fault, right? We see a bit of more risk willingness in maybe smaller agile companies that where it's in their control. The people who invest in it, they take it in their hands. They won't leave it to anyone else to make it a success. It becomes their success, and they would adapt their workflow to make it happen. But I mean, there's also geothermal drilling companies out there that base their business on coil tubing drilling. There's a few that only do coil tubing drilling for geothermal. Because there's a number of things you can add on to it. I haven't talked about any of that, but you can put a lot of extra things on it if you need to. And as you said, if you want to drill deeper, that's the advantage just keeps growing. But if we manage to get few more systems out there successfully, I'm sure that's going to show the way. We see it in minerals here in Australia, where it's been a slow uptake, but it's starting now. Yeah.
Yeah, that's I do see it a lot more in minerals than what we had.
Mm.
And from a compactability standpoint, we talk about tool handling, but just in moving tools, having 1,000 foot roll seems a heck of a lot better than having, you know, 50 20 foot sticks.
Mhm.
So
Yeah. It's all on the rig. You would not know the difference whether you're putting your rig up, whether you have 1,000 feet of drill string on it or not. It doesn't. The rig doesn't behave differently. You need to put your mast up and your jack legs down, and there you go. Um, so yeah, and between drill sites, you also don't have to take your coil off. It fits. If you load it on it, the model we have is crawler mounted because it needs to get into very constrained spaces sometimes, as you are aware. But you put it on a low loader and it fits within the profile of road transport. You do have to take the downhole motor off when you're transporting between different drill sites, not between holes, but between drill sites, you have to take a downhole motor off. But that's just what you do. Yeah.
how long is the BHA and the motor?
It depends a bit on what you're drilling with, but around 20 feet, plus or minus. Yeah, plus or minus. Yeah.
How do you start the hole?
You can start it with the in you can start it with a downhole motor. So you just start drilling with the rig. So you basically eject your mast and you start drilling like you would do with a drill rod. I mean, you still have a drill bit rotating in the end. You have to determine at some point in time whether you want to put in top casing or not. there are versions available if you're in an area where you need top casing consistently. You can have a rotation unit on it as well, so you can use it as a conventional rig as well if you need to do that. In some of the geothermal projects that we have seen, if you need top casing a lot of the time, you have another drill rig coming out, putting all the top casing in if you have hundreds of holes, right? But you just start the hole like any other drill rig. But if you do have a rotation unit on it, you're back to conventional thing. You have to have some drill rods, you have to have your casing, all of that. Yeah.
Sure. With the time we have left, you're in Australia, you have a team, and you're building rigs yourself. How did you get there? How did you determine this is the rig, talk about your company some.
Yeah, I mean, we have been here in Australia, as I said, for 10 years, developing these kind of technologies for the minerals industry. You can say for a period we have been working. I come from the industry. I am probably the least academic, academic person. That I don't consider myself academic. But technically, we're also working for University of South Australia, and that's a different university than many conventional universities, right? It's a university that has more than 2,500 industry partnership across the globe, right? And always looking to grow. You can say it's international partnerships, and it's very innovative, and it's very much about building stuff that can transform stuff. And the university has been working for the minerals industry. We have developing this equipment, starting at a point, will it work in minerals, or how will it work? And can we actually make it cost competitive, productive enough in an environment that is totally different than what oil and gas is? And I mean, talking about the coil life is one thing, but there's a number of issues that needs to be right to make it efficient. So you can say those research, you can say ventures operates for a period, and you can say we've come to a point where those technologies are commercialized. There's commercial builders of these systems. There's also commercial operators. So, I mean, I've been working in the geothermal industry, you can say, with conventional drill rigs. And you can say the opportunity for improvements are definitely in the geothermal. There's a lot going on. And I really would like the drillers to have a safer, more productive, and easier life. So we've done everything possible to put adapt what can be adapted from the geothermal industry into this. Started, you can say, a company last year, you can say some of the leading, if not, most of the leading individuals in designing this equipment. You can say, and that's everything from mechanical to electrical and mechatronic engineers, delivering really all the expertise into this. So we have this center of excellence about coil tubing and all the aspects of it outside oil and gas, right here in Adelaide. And I mean, it's not that, it's going really well with the geothermal industry in North America, and they have reached out, you can say, to see if we could do what we are doing for them now. And that's actually how it started with, let's say, a pull from drillers, which is because they see the advantages and the stuff that were on the market was not quite right for them. So how could we make something that would, integrate it into geothermal is probably explanation, supported by the university as well. They're very much about supporting startups. So we have support from them. We have a really good manufacturing base here in Adelaide. It manufactures for defense and mining, so it's high quality, high efficient. You can say manufacturing systems. We've built coiled tubing drill rigs here in Adelaide, so the supply chain is here, the quality is here, the technical expertise is here. That's how it started, and we would like to do much more in North America. And if it makes more sense in the end to do more in over there, we're definitely open to that. But right now, the expertise is here. Still using a lot of US products, so kind of we have to we're fulfilling US emission standards, US coil tubing, all of the you can say some of it is from your end as well. Yeah.
That's excellent. If people want to reach out to you, what's the best way of contacting you?
Oh, they can go to our website potentially, coilrig.com is the website, or they can send us an email. Our contact info will be there. We haven't showed all the details about what our latest product look like on our website because we're still we'll have the first rig operating in the US next year, and then we will you can say before that we'll show what the actual product look like. Yeah. Coilrig.com is the way to find a way to us. Yeah.
Excellent. Thank you for your time today. It's awesome. And since it's Wednesday here and Thursday there, can you tell me the lottery numbers back here in the United States so I can get out there and win them?
Unfortunately, I can't. I wish it worked like that because if it did, I would just build all the drill rigs and send them for free for the drillers to go nuts.
Well,
Yeah.
thank you. And yes, industry. I got to meet Soren and his wife and partner in Manhattan, and we got talking about drilling and coiled tubing rigs. And this industry is insanely small, and he's designed and worked on other types of rigs. And there's just so much here, and he loves to share knowledge. And you can see it. Check out their LinkedIn and the team that they have built, and reach out. Like, it's got to be the best tool for what we're applying to. And sometimes that will be conventional rotary, and other times we can get into, advancing this industry and finding out what would happen if we say why not and drill with a shoestring, as it was referred to today. I'm excited to see this rig here in the States, and pay attention to what's happening, because it's always fun to be on the leading edge and seeing how we can advance this industry. So thank you for coming on today.
Last thing I would say, I mean, I've seen, the system works. It's not about whether it works or not. It definitely works, right? So I'm sure it has a big future, and we're very keen to work with somebody who wants to take this on. And with that said, thanks for having me, Brock. Yeah.
Thank you.
Thank you, Soren. This was so insightful, and we appreciate your time. And industry, we have an opportunity right now, from ground source geothermal heating and cooling to power generation hot rock. There's lots of innovations happening, and those innovations are happening within the United States, and they're happening around the world. We need to be looking at all aspects. I want you to think again about the PDC bit that was invented by GE in 1973 and didn't get wide-scale adoption until the early 2000s. And when it did get wide-scale adoption, it didn't start here in the United States. So again, think about what Soren had to offer. Think about all the opportunities and how we do the least amount of impact to the environment and to the public and our neighbors. And we can do better. Check out thedriller.com for all the latest. Johnny O'Donnell is doing a heck of a job there. We're always looking for contributors. I want you to go have a safe, productive week. Thanks, everybody.